I am Dr. Sapna, Assistant Professor, Department of Environmental Science, PSC College of Arts and Science, Coimbatore. Today's topic is satellite remote sensing. We know remote sensing is an emerging technology that's used in environmental science field for solving various real life problems like water pollution, air pollution, soil pollution, solid waste pollutions, etc. So, we can have a look on what is a communication satellite. So, communication satellite is an artificial satellite that transmits signals through a transponder and that create a channel between the transmitter and the receiver that located at different positions on the earth. So, this picture it is a natural satellite you can see here. So, a satellite is a moon, planet or machine that revolves around a planet or star. See for example, Earth is a satellite because that revolve around the sun and moon is revolving around the earth. So, this is another pictures that shows the artificial satellite. See, artificial satellite is any machine that launched into space that moves around the earth or another body in space. So, this picture shows the first artificial satellite, that is Sputnik 1. It was launched by this Soviet Union in October 4, 1957. So, the main purpose of this Sputnik 1 is nothing but detecting these temperatures of the space. So, this is orbit. So, the path a satellite follows around a planet is defined as a orbit. Now, let us look into various characteristics of the orbit: apogee, perigee and inclination. So, apogee is the farthest point on the orbit of a satellite from the earth and perigee is the closest point on the orbit of a satellite from the earth, and inclination it is determined by the angle it makes with the equator. So, this is a perigee, apogee. So, perigee is the nearest point and apogee is the farthest point. Satellite orbits are classified into two categories: non-geostationary orbit, that is NGSO, and geostationary orbit, that is GSO. So, now let us look into geostationary orbit. So, geostationary orbit, they occupy an orbital position 36,000 kilometers above the earth and remains a stationary position relative to the earth position. So, the world's major existing telecommunications and broadcasting satellites are fall under this category. So, this is geostationary orbit. So, it moves like this. Next one is non-geostationary orbit. So, non-geostationary orbits, they occupy a range of orbital positions and do not maintain a stationary position, but instead move in relation to the earth's surface. So, this picture shows the GSOs. Next one is polar orbit. As per the orbital plane, NGSOs are classified into polar orbit, equatorial orbit and inclined orbit. So, this is the polar orbit. So, here satellite moves from pole to pole, the inclination is 90 degree. This is equatorial orbit. So, in equatorial orbit, the orbital plane that lies in the equatorial plane of the earth and the inclination is almost small, or we can say it is 0. This is inclined orbit. All orbits other than equatorial orbit and polar orbit is called the inclined orbit. Next one is a geosynchronous orbit or GEO. So, according to the distance from the earth, satellite orbits are divided into different categories. Geosynchronous satellites is they placed in geosynchronous circle above the equator from west to east direction, and they takes 23 hours 56 minutes and 4 seconds by travelling at exactly the same rate of the earth rotation. So, this makes satellites in GEO appear to be stationary over a fixed position. So, in order to perfectly match the earth's rotation, the speed of GEO satellite should be about 3 kilometers per second at an altitude of 35,786 kilometers. This is second category, that is medium earth orbit, otherwise called MEO. So, the region of space in between the low earth orbit and the geostationary orbit is called the MEO. So, the orbit is in a distance of 2000 to 35,786 kilometers from the earth's surface. This orbit is ideal for navigation and communication satellite. Next one is low earth orbit, otherwise called LEO. So, this name suggests that the orbit is relatively very close to the earth's surface. So, it is normally at an altitude of less than 1000 kilometers, but could be as low as 160 kilometers from the earth's surface. We are explained about satellite communication. So what you mean by a satellite, communication satellite, natural satellite, artificial satellites, and we already discussed about the orbital plane. So there are different categories of orbital planes, and these orbital planes where this satellite is placed, and this satellite is transmitting signals towards the earth, and it detect the object and information about the object, and solving real life problems like pollutions, and these backscattering signals are converted into a digital form, for example aerial photos or a map, and these maps or aerial photographs we are using for interpretation, analysis, and finally in decision making. Thank you.